So this video is going to review how to find the domain and range given a graph. As we can see, the domain is the set of all the inputs, which is usually the x values that are on our graph, or sometimes that could be on our graph, depending how big or small our graph is with limitations of paper. Same thing with the range, it's a set of all the outputs, which are normally the y values that are currently on our graph, or that we could put on our graph if we made a huge graph. So here's our first example. We're going to start with the domain. So the domain is the x values, and we know just by looking at the graph that the x-axis goes left and right. So what we're going to think about is, where would I put like borders? What's the first x value that's on our graph, and what's the last x value that's on our graph? So a really nice way to do that is to simply use vertical lines. And we're going to ask ourselves, where would I put that vertical line when I touch my first x value? So like here, there's no x values on my graph. There's no x values, there's no x values. The first x value I see on my graph is right there. I'm going to do the same thing again and ask myself, well, where would I put my last x value? Where does my graph stop having x values? So this vertical line still touching my graph, still touching my graph, still touching my graph, and it's still touching all the way until here. If I go further, there's no graph there anymore. So this is my last x value that's on the graph. So what I can see is that my x values, this is -5, and this one is +5. So just visually, I can see that my x's go from -5 to +5. Now how do we write that? Well, as an inequality. We know that our x values will be less than 5, but bigger than -5. And as we can see here, because of that closed circle, we know that we can use the x value of 5, but because of this open circle, we can't. Now to find the range, it's essentially the same idea, but we know that the range is the y values, and the y-axis goes up and down. So what we're asking ourselves is, where would I put my vertical line, or excuse me, my horizontal line at my first y value? So now since we're not dealing with x's, we're going up and down with y's. So this vertical bar is going to represent my y values. So where's the first time my y values touch the graph? Well, we're not touching there, we're not touching there, we're not touching there, but we are touching there for the very first time. And I need to find, where would I put my last border? So I take another vertical line, and I'm going to follow it up my graph. So it's not touching, not touching, obviously starts to touch there. It's still touching, still touching, still touching, still touching, still touching, and then this is that point where it stops touching, right there. So now I can visually see that my range is between those two values. This vertical line here, or horizontal, is at -4. This line up here is at 6. So our range, which is our y values, we know that they're between 6 and -4. Now similarly that we did with the domain, we got to look at the circles. So here at -4, that circle's not filled in, so we can't actually get to that value. We can get really close, but we can't use it equal to. But up here at 6, that is filled in, so the y value of 6 is on our graph, so we use a less than. So this is our range, and this here is our domain. Now this graph is slightly different. We'll notice that this graph now has arrows. Now what do arrows mean? Arrows remind us that this graph is continuing in the same pattern forever. So we have to ask ourselves, what direction is this arrow going? So this arrow here, see how this graph is going down and to the left? So what that means is that this arrow means our graph is going to go down forever and left forever. If we follow the line this way, I can see that my graph is going up and to the right. So the arrow up top there is indicating that, hey, although you can't see it, this graph would go up forever and it would go right forever. So if we think about doing our domain first, we'd have to ask ourselves, well, where would you put your vertical line at the very first x value? So here's my vertical line. I'm asking, well, where would I put it? Well, obviously it's touching here, but like, how far left do I need to go to put my first x value? Well, according to this arrow here, we are going to go left forever. So where would I put this vertical line if I'm going left forever? Well, what number is left forever? Well, technically, the number that's left forever is negative infinity. And likewise, where would I put my border on the right? Well, I'm asking where do I stop touching my graph here? But again, according to this arrow, I'm going to be going right forever. So where am I going to be able to put this? Well, what's right forever? That's positive infinity. So what I can see here is that our domain is just all the real numbers. Now, they're not all graphed here, but if I had enough space, I would be able to graph any single x value that I could ever think of. And likewise for the range, we're going to look at the same thing. We know the range is now our horizontal line, so we can look at the y-axis. Now, where would I put this at the bottom of my graph? Well, this arrow is telling us that my graph is going to go down forever. So where would I put this line if it goes down forever? Well, the number that's down forever is negative infinity. And then likewise, where would I put this on the top of my graph? If I kept going, this arrow is telling us that we're going up forever. So where would I be able to stop and put this border if I keep going up forever? Well, that's positive infinity. So we're saying that we have all real numbers for our y values as well. Any single number you can think of, it's a y value on the graph. Like 2.16. Well, here's 2 and here's 3. So 2.16 is like right around there. Sure enough, it's on our graph. Same thing with the x values. Pick an x value, 0.000001. Well, that's somewhere right there. And sure enough, that's on our graph. So looking at our domain here first, we have to think about what is the farthest left x value that I would place my vertical line. So I draw my vertical line, but I can see here that this arrow is really going to tell me two things. It's going to say that we're moving left forever and that we're moving up forever. So if I'm thinking about where would I put this, I'm going to go left forever. So my first border is going to be at negative infinity for my domain. Now, same thing with my right side here. If I put a vertical line and ask myself, well, where would I put this as my last x value on the graph? Likewise, this arrow is going to tell us that we're really going right forever. So where would I put this border if I go right forever? Well, right forever is positive infinity. So my domain is all the real numbers. Now with our range, we've got to ask ourselves, what's our lowest y value that's on the graph? So here's my range. Now, where's my lowest? Well, right there. I can see that my graph doesn't go any farther below that. Now, where would I put my ceiling on this function? Well, if I keep following up, when am I going to stop going up? But again, these arrows are going to tell us to go up forever. So where would I put this if it's up forever? I can't put it anywhere. So up forever is up to infinity. So I can see that all the y values here, if this is 0, they're all above 0. So we have our range. The y values on our graph are all bigger than or equal to 0. So looking at this graph, let's look for our domain first. So our domain is our x values. So I'm going to use my vertical line because x values are the same up and down. So where would I first put my vertical line? What's my first border? Well, I see this arrow. This arrow is going to tell me that I should be going left forever. So where's my first border? Well, left forever, which is all the way over to negative infinity. Now if I think about where do I stop putting my x's? Well, okay, I'm still touching, and then I get to here. Notice that there's a circle there, so there's no arrow, so it stops. So I can see that my x values go all the way left to negative infinity, and they come all the way here, and they stop at 21. So my domain are all the x values that are less than or equal to 21. For our range, we can see on this one that it's very easy for me to put a top, like what's the highest point on my graph. So the highest point on my graph is clearly right there. Now, where's the lowest point on my graph? Where would I stop putting this? Well, I'm touching. Now over here it says stop. But if I make my line nice and long, let's get that long line here. Where am I touching my graph? Well, I'm touching my graph still. I'm still touching. Now you'll notice I stopped touching over here. That's okay though, as long as I'm still touching somewhere. And when I look at this arrow, it's going to tell me that we're really going to go down forever. So where am I able to put this? Just down forever and ever and ever. So I can see that my range, the highest number is 0, and it's going to go down forever to negative infinity. So how would I describe these numbers? Well, for my range, all the y values on my graph are less than or equal to 0. As a final example, we have our radical function. Let's do our domain first. So where would I put my very first x line? Well, where do my graph start? Well, my graph starts right there. Where would I put my last x? In other words, what's the last x that I could ever possibly graph? So I'm still touching. Now I've run out of graph, but this arrow is communicating to me that we should keep going right forever. So where would I put this border? Well, right forever. And what's right forever? Well, that's the number positive infinity. So I can see here that I'm starting at 0 and I'm going right forever to positive infinity. Now for our range, I can clearly see where my lowest point is. This is the first point on my axis where I touch my graph. Now where would I put my last point? What's the highest y value? Well, I'm still touching, but again, this arrow is going to tell us that we're going up forever. So if I keep going up forever and ever, where am I going to stop? Well, nowhere. What number is up forever and ever? That's infinity. So I can see my y values start here at 0, and they go all the way up to infinity. So to describe our domain, we can see that all the x values on our graph are bigger than or equal to 0. 0, 1, 2, 3, 4, 5. Our range value is, we can see the lowest is 0, and it goes up forever. So the y values are all greater than or equal to 0.